Hello there and welcome to Lower 6 Maths A-Level. This is the practice paper G of the applied as part of the syllabus. So figure 1 is a Venn diagram showing the number of students in a class who read of 3 popular magazines, A, B and C. One of these students is selected at random. Show that the probability that the student reads more than one magazine and show that that equals 1 over 6. So given that it's a show that question, we probably need to go a little bit overboard in showing our workings because the answer is already given to us. 2 marks here are solely awarded for workings. So in this case what we'll do is we'll write out the probability of reading magazine A and magazine B is any of these 2 people here. The number of people who read magazine B and C in this case are 3 people. So the probability that they read more than one magazine, probability more than one, is equal to 2 plus 3, which is 5, out of a total here of 30 people in the class. So that's 5 out of 30, or 1 out of 6. Now, as I said before, when it is a show that question, do go overboard on showing your workings, because all of the marks are going to come from there. Find the probability that the student reads A or B or both. So the probability of reading A or B is going to be equal to any of these 4 students, any of these 2 students, any of these 5 students, and still within the circle of B, these 3 students as well. So we can count those. Even though they read magazine C, they can read it or not. We don't really mind. So it's any of the 4 plus the 2 plus the 5 people plus the 3 people over the 30 people in this class, which gives us 14 over 30 or 7 over 15. Part C is write down the probability that the students read both A and C and explain what this probability tells you about A and C. So the probability that people read magazines A and C, you can see here clearly from the Venn diagrams here that no one reads magazines A and C. They either read A or they read C separately. So this probability is 0. So no one reads magazines A and C together. The posh word for this is that they are mutually exclusive. Okay. Moving on to part D, given that the students read at least one of the magazines, okay, so that's important here before I look at the rest of the question, given that the student reads at least one of the magazines, so now, in my probability, I'm going to exclude these 10 people here, because they don't read any magazine. Okay, let's look at the question now. Find the probability that the student reads magazine C. So the probability that someone reads magazine C is 9 out of, now we're only looking at the people who read at least one magazine, so in that case we've lost 10 people, so now our probability is only going to be out of 20 people. So it's the probability of reading C given that they read at least one magazine. Determine whether or not reading magazine B and reading magazine C are independent. So what this is saying here is that the probability of reading magazine B shouldn't be affected by the fact that you read magazine C. So what I've got here is the probability that they read magazine B and the probability of reading magazine B given that they read magazine C. And hopefully these probabilities should simplify to give the same value, because if they do give the same value, then it doesn't matter that they read magazine C, the probability of them reading magazine B is still equal. So the probability that they read magazine B is out of these 10 people here, out of 30. So we get a 1 out of 3 fraction here. And the probability that they read magazine B given that they read magazine C is equal to 3 out of 9 people in total. Given that they read magazine C means that we're only looking in this circle here now. So there we have 9 people in this circle, and the probability that they read magazine B, given that they're inside this circle here, are the 3 people here. So in this case here we get a fraction that's 1 over 3. And in which case they are equal. So as the 2 fractions are equal, reading C does not affect the probability of reading magazine B. So therefore, yes, they are independent. Okay, right, that's 10 marks for that question.